So now we're going to talk about how we move from Kelvins to degrees Celsius. And I think this is something we are familiar with. But basically, right, when we go from degrees Celsius to Kelvins, we always add 273.15. And of course, when we go the other way, we minus 273.15. One way to remember it is, of course, degrees Celsius is always below Kelvins, right? The corresponding Kelvin value of the same temperature is always larger than the degrees Celsius value. Right, so for example, 0 Kelvin would be minus 273.15 degrees Celsius, right? And 0 degrees Celsius is, well, 273.15 Kelvin, right? So Kelvin is always numerically larger than degrees Celsius. So what we want to discuss now is basically how on earth this conversion came about. And Lord Kelvin, of course, was responsible for figuring out that the lowest possible temperature, which he called 0 Kelvin, is actually minus 273.15 degrees Celsius. So what our good friend Kelvin did was he used something called a constant volume gas thermometer. And so how this looks like is, well, simply speaking, it's just like a little tub of gas over here. So it's a fixed volume and a fixed amount of gas inside. Right, you have some manometer here, perhaps, to measure the pressure. Okay, this measures P. And you have some heating device here, which can change the temperature of this gas. So basically, you are altering the temperature. This is the independent, and you are measuring the pressure. So what Kelvin did was that he was trying to investigate based on the ideal gas law. If he could figure out what the temperature was when P equals to 0, the lowest possible pressure, then he would get the lowest possible temperature. So like all good scientists, he investigated this on a graph, and so he conducted this experiment, plotting pressure, the dependent in pascals, against, at that time, the degree Celsius scale, which was the only scale being used. Right, so he varied the temperature, calculated the pressure, measured the pressure, sorry, and he plotted some points on this graph, and he got something like this with the best fit line, and he said, oh, based on the ideal gas law, PV equals to nRT, keeping V and N constant, P should have been directly proportional to T. And so he expected this line to cut the origin, but it did not. And so he said, okay, what the heck? I'm going to extrapolate this line all the way here to 0 pascals and see what the lowest possible temperature should have been. And of course, you may expect that this was minus 273.15 degrees Celsius. So Kelvin then repeated this experiment with different volumes of gas, or maybe different amounts of gas. He varied V and N. And so what he got was a bunch of lines when he repeated this experiment. But what he realized was they always cut upon extrapolation at the same point, minus 273.15. And that was when Kelvin realized that he said, okay, so actually, I've just put this axis in the wrong place. I'm going to shift this back. Here, this is still PA, but now I call this the Kelvin scale. And I change this to 0. And so that was how Kelvin realized that 0 Kelvin, what is supposed to be the lowest possible temperature, is actually minus 273.15 degrees Celsius.